Here's the version of the universe they sell you in textbooks. Stunning spiral galaxies, glowing nebulae that look like oil paintings, the pale blue dot, sunsets on Mars, auroras. It's gorgeous, it's inspirational, and it's misleading, not in the photos, which are real, but in the implication they carry, that the universe is a place of order and beauty, that things generally hold together, that structure is the default. Because when you actually look at the data, when you go past the Hubble highlights and into what cosmologists actually think is out there, the universe looks less like a masterpiece and more like a crime scene, a vast, indifferent, mostly broken crime scene. And the deeper you go, the worse it gets. Let's start with something you probably half know. Most of the universe, most of it, is stuff we cannot see, detect, or identify. Dark matter makes up roughly 27% of all the energy content in the universe. Dark energy makes up another 68%. That means the ordinary matter you and I are made of, every star you've ever seen, every planet, every galaxy cluster, every atom of hydrogen drifting in interstellar space, all of that adds up to about 5% of what exists. 5. We call the rest dark. Not because it's mysterious or poetic. We call it dark because we have no idea what it is. It doesn't emit light, it doesn't absorb light, it doesn't interact with anything we have instruments to detect. It just is there, bending gravity, shaping the large-scale structure of reality. And we cannot touch it. That's not beautiful. That's structurally wrong in a way that should keep physicists awake at night. And it does. But okay, dark matter. You've heard of dark matter. Let me tell you about the thing that's actually worse. The universe is expanding. Fine. We knew that. Since the 1920s. And for decades, physicists assumed that gravity was gradually slowing that expansion down, that things would eventually coast to a halt or maybe even reverse. Instead, in 1998, two independent teams of astronomers measuring supernova explosions across billions of light years found something that made them genuinely doubt their own instruments. The expansion isn't slowing, it's accelerating. Something is pushing the universe apart faster and faster. We call it dark energy. And here's where it gets embarrassing. The best theoretical prediction physicists had for how strong this force should be was off by a factor of 10 to the power of 120. That's not a rounding error. That's the single largest discrepancy between a theoretical prediction and an actual measurement in the entire history of science. Every decimal place wrong, 120 of them. Now let's talk about where this is all going. Because the expansion isn't just some abstract cosmological fact. It has consequences. Consequences that play out over timescales that break human intuition. Galaxies that are far enough away are already moving away from us faster than the speed of light. Not because they're traveling, but because the space between us is stretching. In roughly 2 trillion years, every galaxy beyond our local group will have accelerated beyond our observable horizon. Gone. Not destroyed. Just permanently unreachable. Any civilization that survives that long will look out and see a single island of stars surrounded by perfect, empty darkness. No evidence that anything else ever existed. No way to discover cosmology. No way to know. Pause on that. The universe will erase its own evidence. And here's the part that should feel slightly too strange. We happen to exist at the exact brief window in cosmic history when that evidence is still visible. In 10 billion years, it won't be. Physicists have a name for this kind of timing, and it forces some very uncomfortable questions about what fine-tuning actually means. To understand how this ends, you need one more concept: entropy. The second law of thermodynamics is the most reliably depressing fact in all of physics. In any closed system, and the universe is a closed system, disorder always increases. Heat flows from hot to cold, never back. Organized structures decay into randomness. The universe is running down, not metaphorically. Literally running down toward a state physicists call heat death, a cold, featureless equilibrium where nothing changes because nothing can change. No temperature gradients, no energy flows, no chemistry, no life, just a uniform haze of particles near absolute zero, forever. The last stars will go out around 100 trillion years from now. The last black holes will finish evaporating. Yes, even black holes eventually dissolve via Hawking radiation, around 10 to the power of 100 years from now. And then, nothing. Not dramatic, nothing. Just the slow, silent end of every structure the universe ever built. If you're still with me, subscribe, because this is exactly what we cover every week, and it only gets stranger from here. Now zoom out to the largest scales, because the universe doesn't look the way you're picturing it. Forget the beautiful images. At cosmological scales, the universe looks like a web. Vast filaments of dark matter and galaxies stretch between enormous voids. The Bode's void, discovered in 1981, is roughly 330 million light-years across. It contains almost nothing, a few dozen galaxies where there should be thousands. Astronomers who first measured it reportedly had a hard time believing it was real. The universe is mostly empty, organized around vast bubbles of almost perfect nothingness. And the filaments themselves? They're not stable. They're feeding galaxy clusters at the intersections, consuming matter over billions of years. Our own galaxy isn't exempt. The Milky Way and Andromeda are on a direct collision course, expected to merge in about 4.5 billion years. Not gently. A catastrophic gravitational reshuffling that will fling stars into completely different orbits, shred both spiral structures, and slowly form a new elliptical galaxy. Astronomers are already calling Milkomeda. Our sun will almost certainly survive, but the night sky will never look the same again. Which brings me to the fine-tuning problem. And this one I want you to sit with. The constants of physics, the strength of gravity, the mass of the electron, the charge of the proton, are set to values that allow complex matter to exist at all. Change the gravitational constant by a few percent. Stars don't form. Change the strong nuclear force slightly. Atomic nuclei can't hold together. The values look, to anyone paying attention, suspiciously specific. Physicists have three options for explaining this. 1. Coincidence, which is scientifically unsatisfying and most physicists reject on principle. 2. A multiverse. We live in one of countless universes with randomly varying constants, and we're only here to notice it because ours happen to work. This is technically unfalsifiable, which makes it deeply uncomfortable for a field built on testability. 3. There's some deep underlying physics we haven't found yet that forces these values to be what they are. Some equation somewhere that makes them inevitable. None of these is comfortable. All three are being actively argued about right now by some of the smartest people alive. So here's where we are. The universe is 95% unidentified material. Its expansion is accelerating for reasons we can't explain. It is thermodynamically committed to ending in permanent silence. Its largest structures are mostly void. Its physical constants look either miraculous or arbitrary, depending on which explanation you find least disturbing. That's the real universe, not the textbook version. And somehow, in a universe that is mostly dark, mostly empty, on a trajectory toward heat death, matter organized itself into stars. Stars cooked up carbon. Carbon built chemistry. Chemistry built you. A pattern complex enough to ask questions about the pattern. In a universe with no apparent interest in being hospitable, we are here anyway, measuring the fine-tuning constants with instruments we built from atoms that a dying star scattered across the galaxy 5 billion years ago. That's not beautiful the way a Hubble photograph is beautiful. It's beautiful the way a thing that shouldn't exist is beautiful. Unlikely, improbable, real anyway. Drop a comment. Which part of the ugly universe hits hardest? The heat death? The accelerating expansion? The dark matter problem? The fine-tuning? I read all of them. I want to know which number broke your brain first.